You mentioned very quickly about profitability, though, right? And I think one thing that's interesting about iX3 and Neue Klasse, it is designed from the outset to be profitable in quick order, right?
Well, we're not in the business of not making money, right?
Right. Well, hello and welcome to a special bonus episode of the Plugged In podcast, recorded in partnership with BMW at Climate Week here in New York City. I'm Patrick George, editor in chief of InsideEVs.
And I'm Tim Levin, senior editor at InsideEVs.
Today, we're talking about circularity in car manufacturing, and this involves everything from the use of reclaimed materials to recycling EV batteries. And it's one of the ways car companies like BMW can make what they do more environmentally sustainable, besides just making more electrified, hydrogen, and hybrid cars. So I'm really excited to talk with you guys about this, because this is not something that's really well known in the space or very well understood, but we'll see if we can fix that a little bit today. Our guests today are BMW's Nils Hesse to my left, Vice President of Product Sustainability, and Glenn Schmidt to Tim's right, who is Vice President of Sustainability Strategy. Nils and Glenn, thanks for joining us, guys.
Nice to be here.
Yeah, thanks for having us.
Very good. All right, let's start by defining terms here, because what does circular economy mean? I think it's pretty understood by everybody that making cars is not a very clean business, and it seems like this is stuff that you guys are doing to try and change that.
Yeah, well, Patrick, maybe I'll take a first crack at the answering the question. I think circularity on the one hand is maybe kind of very simple, and the simplicity of the concept is one of the beauties. But on the other hand, I think it's very, very fundamental. And if you look at really how business or how industry has worked over the last years, decades, or even centuries, I think you will determine that industry has always been very linear, right? So we're extracting resources. We're using the resources to build some sort of a product. We're using the product, and then we're disposing it, right?
At the end of
So
that, it's just landfill maybe or
it's
something.
it ends up somewhere else. At landfill, it's garbage, or it's in the oceans, whatever, right?
Right.
So the industrial model has been very linear, right? And circularity is fundamentally different, right? So you are, yes, extracting material, you're using it, you're converting it into a product, and then at the end of it, ideally, you're reusing it as well. And if you think about it, and I don't want to get too poetic here, but if you think about it, that's really how nature works, right? Um,
Yeah.
Things are always in a closed loop. Things always get recycled. Things always get reused. And I think there's a lot of potential in this concept, and this is something that we're fundamentally convinced about within the BMW Group.
Yeah, so why do you think that historically it was more this linear, something gets made, then it gets thrown out kind of thinking? What's changed? Why are people and BMW thinking about circularity now as opposed to before?
I guess linear concepts are probably easier, right? You're just extracting, you're using, you're throwing it away. You don't really have to put too much, let's say, thought leadership or intellectual leadership into it as well. If you're going to have a product that's circular, you need to be putting a lot of, let's say, intelligence and thought into it in terms of the design. But I think a few things are fundamental. One of them is, I think we all agree, or humanity agrees, we need to be reducing CO2, right? And BMW is committed to sticking to the Paris trajectory. That means year for year reducing CO2 in our footprint. And if you're going to do that, you need to be relying on circularity. That's the one point. The other thing is resources, they are not endless, right? We need to be reusing them. You just can't be extracting and throwing them somewhere, because you have huge piles of garbage and junk everywhere. So there's the resource element in that as well. And then I think there's another layer that we could maybe briefly touch on, and that is geopolitics. The automotive industry is, and I think it's important to make this point, very global, very interlinked, very, very international in terms of supply chains, right? So the whole notion of saying you're going to decouple, that's not going to happen, right? But you can be de-risking, and the world is turning more geopolitical. As much as we'd like to say it's international, and you have freedom of movement, ideas, thoughts, and goods, it is turning more regional. So there's that movement in there as well, to try and have closed loops for those raw materials that are important for a car.
Yeah, I mean, explain more about that, because I think it's easy to understand that, yeah, recycling materials, putting them back into cars is great for sustainability, for CO2 goals. Tell me about the business case of this. You mentioned the geopolitical risk. Like, why invest in this as a business for BMW?
Yeah, I think a circularity concept really checks a lot of the boxes if you do it correctly. I mean, I recently said that it's sort of like it's a Swiss Army knife, right? At a strategic level. So whenever you have a problem, you can just pull it out, and there'll be a little gadget there that can help you to solve things, right? But it's reducing CO2 in terms of your footprint, and I think later on we'll get into a lot of examples or details about that as well.
Yeah.
It is, if you're doing it correctly and you're using the secondary material, it's cheaper, right? Of course, there's an upfront invest. Like any innovation, you're having to invest upfront, but there's a business case behind that as well. And then there's the point of resilience, right? And I mean, I don't want to over exaggerate, but if you really think about it, in this world that's turned more regional and more geopolitical, a lot of the ingredients that you need for a car of the future, so the raw materials for the batteries, the cells, the semiconductors, the chips, even the data that you need, or even the human capital, a lot of that is becoming sort of subject to this geopolitical debate. That debate is probably a very friendly term to be using,
Might
but
I say you're talking about how centralized that is in China specifically? Is that what you mean? Or
well, not just in China as
yeah,
well, right? But if we take China as example, or Asian economies, they've taken a very, very strategic, a long-term approach in terms of building up the value chains for electric mobility and for battery electric vehicles as well. And if you think about the tariff debate, if you think about sanctions that are being imposed or incentives, a lot of those are kind of focused around keeping a lot of these raw materials and ingredients for the car of the future in a selective region as well,
yeah.
right? So um, that really is, I think, one of the other elements as well. If you have closed loop raw materials, then you're also making your business model more resilient, right?
We're going to go into that a little bit later too, but I
Mhm.
wanted to ask, very kind of bluntly, do you think BMW would be doing this if it weren't for such strict European Union regulations around CO2 reductions? Like, there's sometimes that saying like, okay, you're doing this, it's a great sustainability effort, but is it great for the business, or is it because the government in BMW's home turf is pushing so aggressively for this? Or can it be both?
Yeah, that's a good question. Would you have an electric vehicle without regulation?
Yeah,
Um,
probably not.
I mean, you could potentially make the case for the fact that the electric vehicle or the zero emission vehicle is the product of the regulator.
Yeah, I'd agree with
Um,
that. Yeah,
and I mean, that sounds like a pretty radical thesis to be putting out there, but I think there's a certain truth to that as
yeah,
well. But on the other hand, if you think about big innovations, big strides that have been taken by mankind, big technological leaps, they've always been induced by innovation, by an inherent value that you're proposing for the customer,
yeah.
right? And the electric vehicles that are coming onto the market that we have or that we have in the portfolio, they're a strong customer proposition, right? It's not
Mhm.
just a vehicle that we're putting out there to fulfill regulation.
Right.
So the diplomatic answer to your question is it's a bit of both. And it needs to kind of harmonize. It needs to be innovation driven, customer oriented, but you probably do need regulation to kind of set the guardrails as well, to
Yeah,
set the framework. But needless to say, there have been certain areas or regions of the world, and I'm pointing discreetly to European regulation,
yeah.
that have probably overdone it in terms of the regulatory corset that you're putting on electric vehicles or innovation on the whole. And when there's too much regulation that's stifling progress, that's not the right approach either.
You're talking about like the 2035 ban on internal combustion vehicles specifically, or
You were getting my subtle hints. Yeah,
yeah, yeah,
yeah,
yeah. But it's all, besides to what I said earlier about this being driven by regulations too, it's like we believe and we write all the time that this is a better product. It's the apex of performance and efficiency, which is where the auto industry always goes. But in order to do that, it seems more and more like cars have to be made differently, and that's what Tim wants to ask about too.
Yeah, so maybe this is one for Nils. So you guys have three, we want to talk about how do you actually apply these principles, which sound great in theory, to the cars that you're actually building, to the supply chains. Um, you have three principles, secondary first, material selection, and then optimized dismantling. Take us through what are kind of the driving forces behind, how BMW is implementing circularity.
Yes, I think it's very important. We started with the end in mind, I always say. So, what do I mean? We had a look at the recycling and the demands in the recycling process. And so, when we started to develop the car, we already had these principles in mind. So, like several years ago, we implemented them right in the beginning. And I think that was one of the success factors. And you also saw our Vision Circular. We also tested different ways and approaches with this vehicle. And then we had a look at each and every component during the development process. And we reduced, for example, the CO2 impact, and we closed the loop. And you mentioned the different principles. So on the one hand, secondary materials is very, very important. For example, in the rims, we have like 70% secondary raw material quota in the rims. That helps us to reduce CO2, and we can do it even in highly stressed parts and design relevant parts. And the second one, the material concept, we're trying to reduce the number of different materials on the one hand, and also we are trying to the mix of the materials is very important. So at the end of life, if you mix different type of materials, you have to separate them at the end.
Mhm.
And if you have to separate them, it's not profitable to recycle them. So that's what we are working on. And the last one is that it must be easily to dismantle.
Right.
I like optimized dismantling as a term, by the way. Like that's how I'm gonna approach like cleaning out my basement this fall is optimized dismantling. It just makes it sound more interesting. Then, but when you talk about like the materials going into these vehicles, like we're talking about, do they come from former cars or former industrial products? Like what is being recycled to make these new components that wasn't the case before?
Yeah, it's, I think, a mixture.
Yeah.
So we have different sources, and it depends on which material you take. I think in metal, for example, if you're looking at steel, aluminum, there it's quite normal to go this process.
Mhm.
But we tried to achieve higher quotas to get into the cars.
Yeah.
1/3 of the vehicle you see up there is made of the recycled materials.
It's very impressive. Versus, and what would if that's 1/3, like let's say an older, I4 or something. Do you know what the quotient was for one of your other vehicles? And so sorry to put you on the spot, but
I don't have the exact numbers, but we're constantly leveling this up so that we get higher shares, and we are still working on this. I think we'll have targets for the future and for the next years, so we're working on getting higher quota.
yeah, it's very impressive. Do you have more examples of like the elements on that iX3 in particular that are recycled? You talked about the wheels, you talked about some of the interior materials. It was really end to end, right? Any things that really stood out to you as a really impressive effort for materials for that vehicle?
Yeah, I think if you especially look at the battery electric vehicle and you have a look at the whole life cycle emissions, it's very important to reduce the footprint during the production, so in the supply chain.
Right.
And the battery cells, they are about 50% of the CO2, are responsible for 50% of the CO2 emissions in the iX3 you see up there. And without measures, especially in this sector, you wouldn't achieve the goals. And then you have like steel, aluminum, and thermoplastics. And these four material groups are responsible for 90% of the CO2 footprint.
Wow. But you're claiming a very impressive milestone with this car. It's that it will, you believe, break even on CO2 after 1 year to be comparable with, like a gas car or versus a gas car, correct?
Yeah, that's true. That's the difference with the combustion engine car. It has a lower footprint in the beginning. The battery electric car, that's why we put the effort in there to reduce the initial footprint. In the use phase, if you're using energy, depending renewable or an energy mix, that doesn't count that much then compared to a combustion engine car.
Yeah.
And so after approximately 1 year, a combustion engine car and the iX3 will be on the same level. And I think that's very impressive because we started at the beginning of the development, before we take measures, it was like 60,000 kilometers.
Mhm.
And on top, it has the big battery. So we're not comparing like a small battery car. It has 108 kilowatt hours
Yeah.
battery capacity. So that's really quite impressive.
It is, and after that year, it's a zero emission vehicle. So it's that upfront CO2 cost of EVs that's higher. It sounds like you are making progress in cutting that down.
Yeah, I think it gets, and we talked about regulation before. I think it'll get more and more important to get the CO2 footprint down because of the regulation that's coming up in the next years.
Very exciting.
Yeah, so take me through so you have the recycled aluminum in the wheels, you have recycled plastics throughout the car. How do you decide? Like, take me through the thought process of, okay, how do you get to the wheel is going to be 70% recycled aluminum, or, this part is going to use this type of plastic? What are kind of the big, the thought process that goes into like, okay, is it about durability? Is it about, okay, we can afford for 70% of it to be recycled, but 80% it's going to be too expensive? Is it about cost? Is it about the actual quality of these recycled materials? What are kind of the big factors that go into these decisions?
I think all of the ones you
Yeah.
mentioned, actually, because you cannot say it's only one.
Mhm.
In each and every component, I said it before, you really have to think, what ways can I go? And then you have to decide recycled materials has different properties of the material. So you have to test of how much quota of secondary materials, for example, you can you can put into the material so that you get the same quality, the same surfaces, the same durability than with the primary materials. And that's important. So it's really testing, and we are still researching on materials, how to get higher shares of recycled materials in there.
And are these recycled materials, are they inherently, more problematic? Are they inherently weaker, or is it more about you just don't know, so you need to do the testing to see? Okay,
I'll tack onto that because it's
yeah,
like I could see some consumers being like, "I don't want a car made of recycled materials. It's gonna be flimsy. It's gonna fall apart." And clearly, that's not what you want either. So,
No, I think it's the other way around, because w- we have to develop new innovative technologies
mhm.
to get the materials even better than the primary materials are. And so at the end, the idea is so that you don't have to take a compromise
Yeah,
when you're using recycled materials.
very exciting.
And maybe if I can add one layer as well, because you're asking, I think, a really important question. What is the thought process that you have, or the strategic process that you have in a large multinational corporation like BMW? And it really starts with the core principle, and that is, how can you decarbonize? How can you reduce CO2, right?
Mhm.
And in 2019, we committed to be abiding to the Paris Climate Accord, right? That means we have a trajectory where we want to be reducing CO2. And if you're comparing, let's say, the year 2019 to the year 2030, we have the target to get 40 million tons, 40 megatons out of our activities, out of our footprint. And that applies to our scope 1 and 2. So these are activities that we are responsible for, as well as scope 3. And that's the big challenge, our suppliers, the ingredients that we're purchasing, right?
Mhm.
The innovation that we're purchasing, as well as, we call it downstream, right?
Yeah.
The use phase as well, right? And so if you're defining these targets at a corporate level, at a strategic level, then it's one thing to say, okay, we want to be reducing or taking 40 megatons out by 2030,
Yeah.
and we're about halfway there, right, in the year 2025. But you have to break it down, right? And that's where the thought process really continues to say, at a strategic level, we're reducing this amount, this amount of megatons, and then you pass it on to engineering, and then you have creative individuals like Niels, right, with his engineering prowess and engineering team to say, well, how can I translate that into a vehicle that's leading edge, that is
Yeah.
desirable, that customers like, but also has secondary material in it, for example, as well,
Mhm.
right? So it's kind of a top down, yeah, but at the same time, sometimes, and maybe you can touch on this, it's bottom up as well, right?
Yeah.
There's resistance because you'll have heads of product units, right, or heads of plants saying, wait a second, I have to be profitable. Does this work, right? So it's kind of a wrestle, top down, bottom up, and at the end, you have to come up with an agreement.
You mentioned very quickly about profitability, though, right? And I think one thing that's interesting about iX3 and Neue Klasse, it is designed from the outset to be profitable in quick order, right?
Well, we're not in the business of not making money, right?
Right. But
Yeah.
like that kind of first generation of EVs was like that for a lot of automakers. It was like, we take a huge loss on this to get customers in, and we get the battery cost dialed in over time. There's still some companies that are like taking a bath on this stuff. And you're saying this is designed to not be that, to make money instead of lose it, is what you're saying.
That's right. Well, I think part of the innovation process at BMW involves, let's say, being daring, and then taking that innovation ball and just trying to throw it as far as you possibly can.
Mhm.
And we did that with Project I,
Yeah.
right? So we had the BMW i3 out there in 2013, and
Right.
this was ages ago,
Yeah.
right?
Way ahead of its time.
And then, yeah, so it's a trailblazer. And then with that experience in terms of electrification, we tried to transfer it into the rest of the company as well. And with Neue Klasse, it's kind of a similar approach, right? You see the BMW iX3 here. It's the first vehicle with an entirely new generation of vehicles, but we're quickly rolling it out, right? So if a BMW iX3 has a secondary raw material quota of 1/3, that's a trailblazer, right? But at the same time, there's an expectation that the rest of the organization, the rest of the vehicles in our portfolio will quickly close the gap as well, right?
Yeah.
And in the next 2 years, we're bringing 40 new or updated models onto the market that have the neue Klasse technologies, right? So we're not segmenting and saying that's the future, that's innovation, that's old.
All
Right?
these
It's
all these lessons
everything.
about circuit,
Everything needs to become new and
they sort of trickle down to the rest of the company.
yeah.
Yeah. Very
Well, trickling is a really like a sloped type of process. This is like quick,
Uh,
fast.
yeah.
We need
Flooding
another.
instead of trickling. Yes.
Yeah. Okay. Flooding.
Yeah. Fair.
But I think it's important. It's not only the technical part. We also had on how we work, different working model. It's about leadership. It's about mindset. I think this is a very important thing
Tell us more about
because otherwise you couldn't make a complete new generation car in a couple of years.
Yeah.
So we changed the mindset. We set up other teams, other working models, and with Mike Reichelt, we had a really a great leader who was leading the team and who was driving the team forward every day. And I think that's very important too.
Very exciting.
So coming back to the profitability aspect that Patrick mentioned, is there any area in recycled materials where it is currently more cost effective to use something that's recycled? Or in general, is this all stuff where you're, you know, trying to seed this market, trying to build scale in the hope that someday you and others will make it so that this is profitable?
Yeah, I think the first step is to use renewable energies in every process step that you take to produce the components. That's one of the biggest step we are taking, and we have a lot of suppliers. I think that's the challenge with this. We have like 2,700 first-tier suppliers, and the second tier are already 65,000. So we have to make sure that everybody's using renewable energies, and we try to make it transparent at the end. So we have to have a proof point.
Mm-hmm.
So we have to check if they really use it, and only if we can check this and we get it back, then we can talk about it.
Yeah, I think that's the thing that most people in this room maybe do understand, but most people don't, is that, yeah, when you have a BMW, when you see a BMW, not every part in there is necessarily made by the company. You have enormous amount of partnerships and suppliers. And so, yeah, managing that, trying to get them all on board with the same kind of vision, that must be a
Challenge as
challenge.
well.
It's and it's also on the one hand suppliers, on the other hand, if you're talking about transformation of the industry, because if we say we want carbon reduced steel or whatever, well, the companies were not that big player that the steel companies would change and cost a lot of money to change the process. So this is also a long run. We have to create a pull now, but the transformation will take a couple of years until we get the materials we need.
Hmm. And in a second, I want to get to battery recycling, because I think this is one of the really, really interesting parts of circularity. But before that, I mean, are there any other ways? So we mentioned dismantling. We haven't really talked about optimized dismantling. Take me through, are there any other ways in the iX3, say, or that you're working on, where you're thinking about, okay, this is really important to make sure that this part of the car, we can take it apart, somebody can take it apart someday and get these important materials out of it?
Yeah, I think if you think of the future, the car as a resource, then you have to start with the high quality materials. And if you're talking, for example, about a bumper shouldn't end to be a plastic bottle at the end in the next step. We should use it again as a high quality material in the car.
Yeah. How do you ensure that it doesn't end up at the bottom of the ocean, though? It's like, what is the process for repurposing the iX3 when owners had it for 10 years and then or 20 or whatever, and they're done with it? Like, how do you ensure that happens for the vehicle?
I mean, we're not a recycler on our own. So
Yeah.
what we are doing is that we start to integrate these design for circularity principles in the beginning of the vehicle. We will get the iX3 hopefully back in like 15, 20 years. So it'll be on the road. It's quite a long time between building the vehicle and then recycling it.
Yeah, the true end of life.
And so right now we have to enable the technologies to be able to recycle the cars profitable in the future.
Yeah.
And if you create a pool by being profitable with the recycling, then the recyclers will jump on the topic. And that's how you start to close the loop.
Another way of thinking about electric vehicles is the sort of like mines, right, with precious material and resources inside of them with wheels, right?
Yeah.
So you have the lithium in them, you have the cobalt,
So
in them,
mind-blowing
you
to
have
think about.
you have the nickel in them as well, right? And I think, as an EV user, you can say, well, wait a second, I'm not only am I driving a vehicle that's fun to drive, that's exhilarating, right? That will depreciate, but at the end of the day, I have a lot of interesting geostrategic material in my car, and there will be a lot of interested parties wanting to purchase my vehicle in the future so that we can have closed loops, right? And the thing about recycling is it can't be an afterthought, right? If you want to be able to dismantle and recycle your vehicle, like Neil says, you need to be thinking about it in the early stages as well. So that actually happens. And just to give you one example, in Europe, we're working with a recycling company called SKTES to establish closed loops for lithium, for cobalt,
Ah,
for the nickel as well. So already starting to do this to close the loops. And there's an advantage to that, right? First of all, from an environmental perspective, you're not having to extract the minerals and the raw material from some sort of a mine, which is likely to be outside of Europe, right?
right.
With all of the risks that are associated with that in terms of extracting the logistics, right? You're only doing that once. You're actually securing control of the materials as well. You're not having to move them around again, and they are valuable. So you're actually closing the loops again, and you're reducing CO2. So, I mean, it sounds simple, and it isn't. I mean, at a strategic level, it sounds really simple, but if you look at the details, it's very complex. But it's actually so obvious, circularity. It's kind of surprising, to be honest with you, that we weren't doing this earlier.
Yeah, and that's one of the most frequent criticisms that we hear at InsideEVs of electric vehicles. It's like, well, creating a battery, mining a battery is an environmental nightmare. And people say that a lot. Since extracting oil is not a problem at all, really. It's totally great. But it does sound like that's a big challenge you're trying to solve. But battery recycling is still in its early days, correct? I mean, that's a very nascent industry, isn't it?
It is in the early days, and why? It's because, like, look at BMW. We are an innovator and one of the first movers, right? So our first fully electric vehicle that we put onto the market is 2013, and most of those vehicles, they're still out there. So other people are still enjoying them, and the nice news is the cells, they're actually holding up much better than we thought,
Mm.
right? So it will take years or decades before the vehicles start coming back again, so that you start closing the loops. Which means, yes, we will have to be extracting more minerals to support that as well. But the earlier we think about closing the loops, the better it will be. Yeah.
Mhm.
And another big challenge really is the long period of time. So if you look what you get back today, some of the materials are forbidden today. So,
How about that?
if you are going to recycle this, in, for example, asbestos, it's in there,
Right.
it's not allowed anymore.
Yeah.
So, what are you doing with this? Another is if you have contaminations of materials. So that's what we're doing in the research to find ways how to handle. It's called dirty aluminum. How can we handle this, and how can we achieve the same strength with these aluminum?
Mhm.
Yeah, and so you talked about, you have these partnerships, closing the loop in batteries, which is exciting because batteries are the heart of EVs. They're very expensive. Like you said, getting the materials is hard. What does closing that loop actually look like, right? You sell the car to a person. That car has a lifespan. What's BMW's role in making sure that those batteries get recycled at the end of the day, or helping facilitate that, right? What are kind of you doing on that front?
Right. Well, I think it really starts off with sort of having the research and development. So in Munich, we have an R&D center where we recycle vehicles, right? So we are actually taking the vehicles, we're dismantling themselves ourselves. We're looking in terms of, well, what can you learn from the dismantling process in terms of the how to design the vehicles in the future so that it's easy to do this. Then, like I mentioned, we have partners in Europe. It's SKTES. In the USMCA environment, North America, it will be Redwood. So we're working with local partners that have a high competence in the area of recycling and dismantling so that we can work on closing the loops and are starting now to already feed back the lithium, the cobalt, the nickel, these materials that we need into our battery production as well.
Mhm.
So, at the end of the day, it may not be BMW that's producing the cell, but it's our intellectual property. We're designing the cells with our partners together. And the thing about electric mobility, to make the point quite clear, is you can't do it on your own. You need to be relying on partners. So a lot of it is collaboration, working together with the right partners at an early stage to create the incentives, but also to be thinking about the processes and the steps that you need so that when the vehicles come back en masse, right, when you're getting a
Right.
lot of the vehicles come back, that we're prepared. And at the end of the day, it's a strategic advantage. The earlier you're thinking about this, the better you'll be from a strategic perspective.
And we've talked to the folks at Redwood, like one of the most interesting companies in this field, like by far. But like, I wonder, what's the biggest challenge to really scaling up battery recycling in like a perfect world? Is it, do you need like 10 more Redwoods? Is it just that's they go that's one company in the USMCA region, as you said? Like, it's like, what would it take to really do that at the scale that would meet, the electric vehicle future that we're all talking about?
I think one thing is you need to have the right regulatory framework, right? And there's a tendency, if we look at Europe, where there's regulation that's being discussed or put in place for end-of-life vehicles, to say you need to be regulating everything, right? So you need certain quotas, certain parts of the vehicle need to be dismantled and taken out in advance. There even are ideas to say the battery is not part of the vehicle. Those are two things that need to be
That's a
separated
whole other
differently.
thing
But that doesn't make sense, right? Because like you're saying yourself, the battery is the most precious part of the vehicle, right? So if you're taking the battery out and not treating it as part of the used vehicle, then you're taking the incentives out, right?
Mhm.
So I think one of the challenges right now is talking with the regulator and creating the right framework with incentives. But at the end of the day, it's a business like everything, right? So you need a strong monetary incentive, right? And recycling, yeah, it's a profitable business. If you think about these electric vehicles with the precious materials coming back, there must be a real business case driving that. I might fundamentally believe if we have a good business case driving this, that incentivizes everything,
Yeah.
and that will ensure that this thing works.
But it's also very important to enhance the technology of the recycling. Because if you just think about it, if you can easily dismantle the battery from the car, that's the one thing that's important. And the next is if you can put it into a shredder at a hole, and then you're able to separate the materials in the end. And that's the technology we need to develop. Then you're able to scale this process. And if it takes too many steps or too many manual steps and sorting steps, then it won't be profitable. And if it's not profitable, it won't work.
Mm-hmm.
That's why we have to invest into the technology, and that's why we're working with the SK for example, and we are recycling our R&D batteries right now to learn and to find ways how to optimize it.
So does that go both ways? Like when you have these partnerships in Europe, you have a partnership in America. Is it about, working with them? These are the recyclers. They know what can get recycled. You guys are the ones designing the batteries or helping design the batteries. Is the idea to work together and see, okay, how can we make batteries that then we know you can do something with at the end of the day?
I think that's the way to go.
Yeah.
Because if you won't do it, we don't have the knowledge of the recycling in our company. We're doing it in a small scale in our own centers, but the other recyclers, they know how the real life is. And so I think it's very important to to start collaboration with these partners, to learn from each other, and then to scale it together in the next step.
Could we really get to a point someday where we have dramatically reduced or possibly even eliminated mining new materials for EV batteries? Is that really possible, we think?
Well, a couple of years ago, we presented a vehicle that was made 100% of secondary material, right? The BMW iVision Circular.
Yeah.
Right? So let's say at a theoretical level, you could envision a vehicle that's completely made of reused material, right? It's a long way, right? But if you think about it, we're already at 1/3 with the BMW iX3. I mean, Niels
Yeah.
mentioned that very humbly, right? But it's 1/3. That means it's over 700 kilograms of this beautiful vehicle out there that's leading edge technology has already been in use somewhere else, right? So we're moving in the right direction.
Amazing.
And I think that you need to have that vision, right, in order to move in that direction. And ultimately, if we're still harvesting, if we're still just using and disposing, it's not going to work as well. But in order to get the EV park up there, right, replacing conventional vehicles, of course, there will have to be a lot of harvesting still in terms of getting the materials. But the earlier we're thinking about this, the earlier we're closing the loops, the better it is.
Very good.
And I think it's very important that we're not only talking about closed loop within the car industry, it should be industry open, because that's the way
Yeah.
to go at the end.
Yeah, I think let's bring this back around just to close out. Let's bring this around to the consumer. Does this whole vision, does this make better products for the consumer at the end of the day?
Does it make cars more expensive even?
Yeah.
Well, there's always a bit of a premium for sustainability initially. I think that needs to be the case. Maybe to answer the question is the best way is to look at the next generation of battery cells that we're using in the Neue Klasse vehicles. We refer to it as our 6th generation, the round cylindrical cells. So a lot of these principles have been applied there. And I mean, numbers speak for themselves, right? So we've been able to increase the energy density by 20%. You're able to increase the range by 30%. The efficiency is increased by 30%. The amount of CO2 that you're reducing is 50%. And that's where it becomes interesting for the consumer and for us as a business model. Compared to the 5th generation, there's a 40 to 50% cost advantage as well, right? So thinking circular, optimizing, there's potential in there. And you're able to, and I think this is always the fascinating thing about BMW, is that you're trying to take things that seem to contradict and put them together. Efficient dynamics historically is the best example, right? A BMW has to be fun to drive and exhilarating, but you can still make it efficient, right? And you can make a BMW, an electric vehicle, BMW, and this applies to the entire portfolio, make it circular, increase the secondary raw material quota in the vehicle, but it still looks fantastic. It's still exhilarating. It still has a fantastic design. So at the end, it's not a contradiction. It's actually complementing itself.
We won't take a compromise on that because we always have the quality is, we won't talk about this. We would always achieve the premium quality. And so with the recycled materials, it needs to get better. And that's why we boost the innovation by finding new ways and new technologies to produce new materials. And that's at the end, the customer gets better experiences. I think that's important. And if you start it early in the product concept, then it doesn't need to cost more.
Mm-hmm.
Glenn and Nils, this has been such an excellent discussion. In closing, anything that you guys want to add that we might have missed that you think is important for folks to know about on your efforts on this front?
Circularity is lots of fun.
Yeah.
Bottom line.
Yeah.
Yeah.
All right. Awesome. Glenn and Nils, thank you so much for joining us today. Really appreciate your time.
Thank you.
Thank you very much.
Thanks.
Woo!
All right.
Great job. Really great job. Sit down. Thank you.
Thanks, guys.
Thanks as always for listening to the Plugged In podcast from InsideEVs. This episode was produced by Michael Perkins and Mike Roselli, is brought to you by the Motorsport Network in partnership with BMW. We'll be back next Friday as always.
Make sure to follow the InsideEVs YouTube channel, subscribe to our podcast wherever you get them, and check out all our EV coverage at InsideEVs.com. See you next time.
See you next time.